Well, hello functions classes. We are starting a new unit. It's called Radicals. It's brand new material and we're basically going to be learning some new things. We're going to build on some old ideas and learn some new ones. So we did this warm-up in class. Basically what we did, to simplify this without a calculator, we found, so if we find what the square root of 49 is, well that's 7, and if we find the square root of 89, well that's 9, and 7 times 9 is 63. We should be able to do that without a calculator with no problem. Number 2 is a little bit more tricky, but I'm going to rewrite it so that I can think about it in a different way. So I'm going to write it as the square root of 16 over the square root of 25. Well, the square root of 16, I know, is 4, and the square root of 25 is 5. So then that is another way to simplify. So we are going to be asking you guys to do this without a calculator on your test. And I really believe that all of you will be able to do it, and we're going to be able to do it up to the 5th root. We're going to be going back and forth between powers and roots, and the reason why we're going to do that is we're going to talk about it. So radical expressions, we're going to find the roots of numbers, we're going to find principal roots, and we're going to find the nth root of the nth power. So one of the things is, basically what we're going to do is we're going to find the roots of numbers, so we're going to be able to simplify some simple roots. Finding the principal root means finding the real solution, really is what that means. And then the nth root of n powers, we're going to talk about some different rules. So the first thing we're going to start with is finding the roots of numbers. So I went ahead and put perfect squares. So if I were looking at this, this would be 1 squared is equal to 1. 2 squared is 4. 3 squared is 9. 4 squared, 16. 5 squared is 25. 6 squared is 36. All the way to 15. I have this on my wall, and I know Miss Wadley does too. So we know these, and we're fairly comfortable with that. We understand that a perfect square is a number that multiplies by itself to get a number. So like 8 squared, 8 times 8 is 64. So we do know that. So to build on that, we would think about, well, what is the opposite of squaring? Well, that would be square rooting, right? To undo this, to find the square root of that, I'm trying to find what times itself equals 4. Well, that'd be 2, right? And this would be 3. So we have been doing this for a long time, and we feel very comfortable. But what if we were to do it with, like, higher cubes? So I'm going to show you how to do this on your calculator, because I want you to put these in your notes. So I want you to write in your notes, this is what I want you to write. I want you to write x to the 4th, x to the 5th, x to the 6th. And then we're going to write 1, 2, 3, 4, 5. And the reason why we're going to do that, so these are perfect cubes up here. So 1 cubed is 1 times 1 times 1 is 1. 2 cubed is 2. So if you use your fingers, 2 times 2, or 2 to the first power is 2. 2 times 2 is 4. Times 2 is 8. So that's how all of these perfect cubes work. So now we're going to find different powers. So what I want you to do is put this in your notes. So if I were to, I lost my little, there it is. Okay, so if I were to say 1, 1, so I'm going to use kind of my function notation type of thing. I'm going to plug 1 in for x. So 1 to the 4th power will be 1 times 1 is 1 times 1 times 1. So that would be 4. So 1 to the 4th power is 1. Times 4, 1 more would be 1. So 1 to the 5th power is 1. And times 1 more time, 1 to the 6th power is 1. We can do the same thing with 2. So 2 to the 1st power is 2. 2 to the 2nd power is 4, because 2 times 2 is 4. Times 2 is 8. Times 2 is 16. So 2 to the 4th power is 16. Well, 16 times 2, that would give me 2 to the 5th power, 32. And 32 times 2 is 64. So we are going to be asking you to do this in your head and be able to work your way backwards. So I want you to fill out the rest. Go ahead and hit pause and do that. So we're going to do, we know that 3 cubed is 27 because we have it right here. So this is 3 cubed. So what is 27 times 3? You're going to write that number right there. And then I'm going to show you how to find this in your calculator. Okay, so we're going to learn how to find this in our calculator so that when we'll have it written down in our notes, but something we can look at as a quick reference. We won't be able to use this on the test, but it might be something that helps us with our homework until we get more comfortable with these numbers. So what you want to do is go to y equals, and then you're going to want to clear everything else. So make sure you're on the other side of the equal sign and you're going to hit the clear button. So if you go down, hit clear, down, hit clear. Then we're going to go back to y sub 1. So when we're in y sub 1, we're going to use this button right next to the alpha button, and we're going to hit that. Zoom out just a little bit. Then we're going to use our caret key, which is right underneath the clear button, and we're going to put 4. So that says x to the 4th power. Then we're going to do the same thing here, x button, caret, 5. And then we're going to go down and we're going to hit the x button, caret, and 6. So we have 3 things filled out. And we've got x to the 4th, x to the 5th, and x to the 6th. So that looks very familiar. That looks like what we wrote down in our notes. Then we're going to hit our second button, and then our graph button, which is right here. And it's going to pull up a table. So now when I look at this, as long as I remember what I put here, my function there is x to the 4th. So if I put 1 in for x, I get 1 to the 4th power, which is 1. We said that 2 to the 4th power was 16. That's what it has there. We said that 3 to the 4th power was 81, because 27 times 3 is 81. It's right there. You can write that out longhand. So make sure you check your work in your notebook, because I don't think we finished the 3's. So 4th to the 4th power is 256. And 5th to the 4th power is 625. Now remember here, we said that y sub 2 is going to be x to the 5th power. So 1 to the 5th power is 1. Well, 16 times 2 is 32. We found that, and that would be 2 to the 5th power. 3 to the 5th power is 243. 4 to the 4th power, 5 to the 5th power. Then we're going to do to the 6th power. So just to make sure you got all the right numbers, when you hit pause, have that. So that's how you would read that. So this would be the y sub 3 is all x to the 6th power. So now you have that in your notes, and you know how to find it in your calculator to check your answer. It's quickly, you go to work your way backwards. Now if I asked you, what is the 6th root of 64? Well, look, it's 2. We're going to undo it. So we're going to go back to this number. Or if I said, what is the 5th root of 325? Well, I'm sorry, 3,125. Well, I'm going to find that number, and I'm asking for the 5th root, so that would be 5. So we're undoing it. Okay, so we've talked about how if we take something, so if we find the square root of 36, that equals 6, because 6 squared is equal to 36. But another way to look at that would be to take, let's take the 5th root of, we said 3,125. Well, if I take the 5th root of that, then I'm going to get 5. And that's because 5 to the 5th power equals 3,125. And you can check that. So that's what this is saying. This is saying if you take the nth root of any number that's equal to this number, then that means that that number raised to that power is equal to what's underneath the square root, or the nth root. So go ahead and get this put this in your notes, especially this part. This should all be in your notes. So hit pause. So now, this also should be in your notes. We're going to talk about the number A. So when we look at the number A, let me see if I can find my cursor. So this letter A, So the letter A is the radicand. That is the letter underneath the radical sign, or I'm sorry, that is the number underneath the radical sign. The N is called the index, or the order. You'll see index more than you'll see the word order, but both work. And the whole thing is called the radical. So this is, and then this root, the little check with this right here, this is called the radical sign. So make sure this is in your notes, hit pause, and make sure you have it in there. All right, so when we're talking about simplifying, we're going to be undoing. So if we know what to the third power is equal to 27, then we can solve this fairly quickly. That's why knowing your numbers is going to really help. Well, I don't know, maybe off the top of my head, so I know that I don't want to start with 2 because it's not an even number, and I know that it's not going to be 1, and I know it probably won't be 4, so I'm going to start with 3. So 3 to the first power is 3. 3 to the second power, 3 times 3 is 9, times 3 is 27. So 3 to the third power is 27. So my answer must be 3, because 3 to the third power is 27. I can do the same strategy for finding the cubed root of 216. It has to be 6, because 6 times 6 is 36. And then times 6 is 216. So you're going to keep doing that. So try to do this one. Goodness. Okay, so try to find the fourth root of 256. So use your strategy. So it could be 2, but that doesn't make sense because 6 to the third power is 216. So it's 4, because 4 times 4 times 4 times 4. And then the fifth root, again, you're going to want to use your fingers to try to figure out how you can get to that number. So what you're doing to undo those roots, to do the fifth root, is you're going to use your strategies to find what you need to multiply by itself to get to that number. So that is a good strategy. Again, this one, a good way to write this is to rewrite it. So we would rewrite it as the fourth root of 16 over the fourth root of 81. Well, we know that the fourth root of 16 is 2, and the fourth root of 81 is 3, so then that is our answer. So that's what we are going to want to do for these. And then this one, you can do it a different way. So we know the third root of 64 is 4. So we can use that idea. So if we know that, so we could do 0.4 times 0.4, we would get 16, right? Because 4 times 4 is 16, and then we count the decimal places, 1, 2, then we move it 2 decimal places, and we get there, and then we do 0.4 one more time, so then we get 0.4 times, that's going to be 4 times 16 is 64, and then we have 1, 2, 3 decimal places, so 1, 2, 3 decimal places, so we get that, so then our answer must be 0.4. So you can use your different strategies to do that. All right, and that is where we stop today. So go ahead and get all of that in your notes. I hope to see you soon in class. If you have questions, please let me know. I did go through that pretty quickly, so hopefully you'll get some practice. You should be able to do 1 through 12 in your homework, and it's all posted on Google or on my math lab. So have a great night.